like, share, and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back to the YouTube channel. This is Jonathan Goldfish. So for this video today, we are going to enter the new chapter of the FP1, which is the chapter 2 rational functions and graphs. As what I have promised that we are going to continue the FP1 syllabus from the previous video, chapter 8 integration part 2. Alright, so let's get started. Okay, here is the first subtopics, which is the limits at infinity. So this concept needs to be used because this is to determine the asymptotes. But what is the type of the asymptote? Let's look later. Alright. So the limits at infinity. Okay. So first, let's define what is limits. Alright. So the limits, what is limits? Limits is the value of that fx, okay, as the value of the x approaches the value of the a. Alright, so here is my mistake that I accidentally put the x as a, so please change it to x, alright? Okay. So to represent the limit, we put lim, not the surname lim, okay? So the limits means that this value, when you substitute the a, okay, this x only approaches the value a, okay? X does not exactly equal to the a, alright? So this means that the value of x gets closer to the value of a in order to get its limit value of the fx when you substitute the x equals to a inside. Okay, provided that this limit series converges. Alright? So the next thing, we are going to define about infinity. Alright? So in the rational function graphs, of course it involves the reciprocal functions. Okay? Which is the 1 over x. So everyone knows that 1 over x referring to the x. You see the x is the denominator. So we know that the denominator cannot be 0. Okay, because 1 over 0 is undefined. But what is the situation when it is defined as infinity? Only it takes the limit to describe its infinity. Alright? So generally, the limits of 1 over x as the x goes to the above or below 0 to get the infinity. So this is how does it define. Alright? So hence, the limits of fx as the x goes to infinity is the limit value of flx after you have applied these two concepts, which when x is infinite, when x is approaching infinity and 1 over x is approaching 0. Okay? So just now what I have asked is, what is the purpose of using the limits at infinity? So here's the aim. So this aims to find the horizontal asymptote of the rational functions. Okay? So what is the horizontal asymptotes? We will explain this later. Okay? So how does this work? Okay, first you have to simplify the fx until you see a term of 1 over x. Okay? Because if you suddenly simplify the fx but you can't get the 1 over x, okay, that limit is said to be divergent. Alright? So after you have obtained the 1 over x seen, take the limits as x approaches infinity. Okay, then substitute the 1 over x as 0 after the limits. Okay, so why as x goes to infinity, the 1 over x approaches 0? So here is the reason. Let me write over here. Alright? So we have 1 over 10. What is it? It's 0.1. Okay? What about 1 over 1000? Is 0.001. Correct? Now we increase the value of the denominator. We try and see. So what you can see over here, the denominator value is very large, meaning that the value of the entire value gets smaller and smaller. So this will get something 0.0000, and what you can see, this signifies that the limit has to be used. So this is to get the 0. So that's why limit is very important for finding the horizontal asymptote or the y values of it. Okay? So if you can understand about the concepts of the limits, especially in its infinity, okay? So now we can proceed to the next subtopic. Alright? Okay, so here is the actual topic for the chapter 2 rational functions and the graphs, of course. Okay? So rational functions, I have been abbreviated to RF. So from now on, I don't call it rational functions, I call it RF. Alright? So what is the general form for the RF? So there is a function given y equals to fx is equal to the px over qx, where the px is known as numerator functions and qx is the denominator function. Okay, so over here, px and qx are both polynomial functions. So from now on, I will call px is degree of the numerator, qx is the degree of the denominator. Okay, for the both polynomial functions. Okay, so no worries that in the Fundaments 9231 syllabus FP1, the degree of the polynomial for rational functions is at most 2 only. No worries about it, alright? Okay, so let's move on to asymptote. Okay, this is the important point, alright? Very important. So what is asymptote? Alright, so asymptote is a dashed line for which the rational graph does not intersect with it, which means that its domain or range is not defined for the rational functions. Okay, so here's the simple, here is what I define the asymptote, about the asymptote. Alright, so asymptote can be known as the line of the tangent to the curve, but the curve does not touch it. Okay, as x goes to infinity and y goes to infinity. So how does it work? Alright, let's refer to the following 3 types of the asymptotes. Okay, so as it has stated that x and y coordinate do not define the fx. Yeah, that statement is correct. It's the similar thing that what I have explained just now. Alright, so asymptotes consist of 3 types of asymptotes. The first is the vertical asymptote. Okay, why vertical? In mathematics, you have learned what is the vertical line refer. What does vertical line refer to? It is x equals to something, meaning that its x value moves to the left or right like this. Okay, what about the horizontal line? It is the y equals to something, meaning that this horizontal line moves up or moves down by depending on the y values. Okay, so for the vertical asymptote, it is a vertical dashed line like this. Okay, so this is called the vertical asymptote when x equals to a and the x equals to a does not define the fx. It's fx, where fx is the rational functions. Okay, so to find its asymptote, you need to let q equal to 0. Okay, as fx goes to the infinity. Okay, so this qx will be 0. Then you have to solve the qx equals to 0 to get the roots. So that roots will become the equation of the asymptote. And then you draw a dashed line like this. Okay, turns out that the x equals to a is the vertical asymptotes. Alright, okay, the next type is the horizontal asymptotes. Okay, y equals to b. This is the general equation of the horizontal asymptotes. Okay? As x goes to infinity, the fx goes to b. So over here, we have to use the limits like what I have explained over here. Okay? So to get the YB or the equation of the horizontal asymptotes, you have to take the limits of fx as the x goes to infinity by simplifying the fx until the term of 1 over x is seen. Okay, then you substitute 1 over x equals to 0 inside to get the horizontal asymptotes. Okay? So if it is not a horizontal asymptote, it can be the oblique asymptotes. So what is oblique asymptote? So it is an asymptote which its dashed line is not a horizontal line, but instead it is a slang line, not slang line. It's an angle line, all right? It's a slope, sorry. It's a slope line, all right? Just like this. So everyone knows that the slope or the slope straight line has the general equation of standard general equation of y equals to mx plus c. So this goes to the same thing. Okay? As x goes to infinity, the fx will be approaching the ax plus b. So that, which means y equals to ax plus b will be the oblique asymptotes. Okay? By referring to the previous one, which is the limits of fx as x goes to infinity. Alright? So when fx is an improper fractions, okay, this happens when the rational function is an improper fractions. Okay, so the long division is required to obtain the y equals to ax plus b and then the rx qx. So the y equals to ax plus b is the oblique asymptotes. So over here, if you caught of an fx is the improper fractions by referring to the degree of the p and q. So obviously, apparently, the px degree is greater than the qx degree. Therefore, long division has to be carried out. Okay, so this long division, the long division method is included inside from 9709 Basic Maths Paper 3 Chapter 1 Algebra. Okay? So how to do the long division, I don't have to teach you because this is the previous chapter. This is the previous chapter, okay, for taking the further maths 9231 FP1, alright? So see, Rx, I'm gonna explain over here. Rx, this is the clarification. Rx is the remainder function and Qx is the divisor function from the original improper functions over here. Okay? And then ax plus b is the quotient actually. So the quotient will be the oblique asymptotes in the form of its in the straight line equation or intercept form. Okay. So I keep pronouncing vertical asymptotes, horizontal asymptotes, and the oblique asymptotes is time wasting and or time consuming, and it is troublesome as well. So instead, I will pronounce it as VA, HA, and OA. So from now on, there are another aberrations of the pronouncing these three types of asymptotes, which are VA, HA, and OA. So next time, when it comes to our exercise discussions, when I said VA, HA, and OA, you have to understand what I mean. What does it mean for the aberration, including the RF as well. Okay? So far, if you're clear about this, let's move on to the next subtopic, which is the most important part, which is the graph sketching of the rational functions of the RF. Okay, alright, let's move on to the next subtopic, which is the graphs of the ratio of the RF. So finally, we are touching the most essential subtopic among this chapter. Okay, so here is the procedures of how to sketch a ratio an RF. Okay, a RF. All right. So here are some procedures that you have to undergo. So the first step is to find all the asymptotes. And remember, in the 9231 syllabus FP1, okay, rational graph only has at most 2 asymptotes. So no worries about it. Okay? Meaning that the range you must use the b square minus 4ac is greater or equal to 0. Yeah, I think so. Okay, here's my mistake. So it must have an equal sign. Okay, so this discriminant has to be used for finding the range of the rational function or the range of the y. Okay, so for VA, solve Qx equals to 0 to get the solution. That roots will be the equation of the HVA. For HA, take the limits of fx as x goes to infinity to get the equation of the HA. Oblique asymptote, generally, when the rational function is in proper fraction, you take the long division, and that quotient will be the OA to be formed an equation. Okay? So here are the general form after the long division has been undergo. Okay? Okay, for the second step, you have to find all the intercepts when x so x-intercepts of course are x-intercept and y-intercept. So to find the x-intercept, let the y equals to 0 to solve for the x. Y-intercept, you let the x equal to 0 to find the fx or the y value. I mean the y-intercept, alright? Okay. Find the domain and the range. Okay? So what is the tactic way to look for the domain? So you have to use the fact of the qx equals to 0 or equate the denominator function to 0 to find the domain of the function. So usually for the rational function, the x subsets to all real numbers except the x equals to a. Okay, here is another mistake. My apologies. This should be equal sign instead of unequal sign. Alright? So where x equals to a is VA. Okay? So please remember about this fact. Usually x subsets to all real numbers for the RF except the x equals to a. For x equals to a is the VA. Alright? Okay. What about the range? Of course, the range is the range of the y or range of the RF. So of course, the HA or OA must be eliminated for sure. Okay? So how to do so? You have to use the discriminant of the b square minus 4ac is greater or equal to 0. Why? Because in the reciprocal functions, they are up and down, but they are opposite to each other. Okay? And there's no adjacent graph beside, above, or below them for each other. Okay? So this makes a perfect sense that you have to use the discriminant which is greater or equal to 0. Because the y consists of not only one solution but 2 distinct solutions, probably. Okay? Where x is the only variable in the quadratic equation in terms of the y, not the x. Okay? Oh yeah, x is the only variable in the quadratic equation, so it is dependent on, you have to take y instead of x. And then you take the discriminant you solve for the range of the y. Okay? And the fourth thing is you have to find all the turning points. Okay? So how to get the turning points? So ask yourself, what is turning points? It's stationary point, right? So how to get the stationary point? This one we have covered from from where? 9709, paper 1, chapter 7, differentiations. Okay? Is the derivative that equates to 0 to get the stationary point, right? So you have to use the fact about it. Okay? However, for the rational functions, since it is the rational function that involves the division, of course, quotient rule has to be used, usually. Okay? So you have to, actually this quotient rule, you will learn in the 9709, paper 3, chapter 4, differentiations. But since you are taking the 9231, so you have to learn this earlier. But I believe that you have these fundamentals from your secondary school, alright? Which is the quotient rule. So how to get the quotient rule, px over qx, how to get the derivative of this entire function, which is the keep the bottom multiplied by differentiate the top minus the keep the top multiplied by the differentiate the bottom divided by the square, the entire square of the bottom function. So this is it for the derivative. And then equate the derivative to 0. It doesn't matter because eventually the denominator square will be cancelled because it has multiplied to 0 already. Okay? Then solve for the xp, where p is the critical value of the x from the stationary point, or the x coordinate for the stationary points. And then you substitute the point x equals to p, or many and many, or multiple critical values of x inside the original rational functions to get the y values. So hence your stationary point or points have been obtained for the turning points of the rational functions. Okay? And fifth, this is the most crucial part. What is it? It's the behavior of the RF curve. So what I have outlined just now, it is for the general reciprocal graph, it's either left top, right bottom, or right top, left bottom. And its adjacent, what does the term adjacent mean? Beside of the graph, above or below the graph shouldn't be axis. Beside the graph, alright? So here is the prompt. Okay, in the real CIE exam, it only gives you the blank space for graph sketching. Okay, remember that every A-level external examination for 9231 FP1 paper 1, for the rational graphs RF graph sketching, it only gives you a blank page. That is the space for you to sketch the graph. So here are my tip is how to sketch the RF graph properly. So you have to occupy the blank space at least 75% of it. Okay? Because if you draw too small, your marks might be deducted. And this will give the threat for your overall marks. Alright? So for the marks guaranteed, please draw the RF graph properly and occupy at least 75%. So I will teach you how to do the RF graph sketching practically. Alright? So for A, how to check the behavior and direction of curve? Okay? First thing, you construct the both x and y axis for sure. Okay? This is the general Cartesian plane. Make sure it consists of 4 quadrants. And then draw the both axes. Why I say both axes? Because in the FP1 syllabus, RF only consists of 2 asymptotes. Okay? Which can be either VA, HA, or VA, VA and OA. Alright, so this is the OA, this is the VA, this is the VA, and this is the HA. Okay? And plot the stationary points, if any, and the x-axis of the intersections. Okay? So for the points plotting, you do have to be the points doesn't have to be accurate, okay, to save the time. So just state the intersection points will do, okay, if the question asks specifically or particularly. Okay? And then of course you can use the calculator to evaluate each y value. What is the change of the y? X increases or y increases. So what are the variations? Okay? And here are a few general patterns must be obeyed. Okay? So where these two lines are the asymptotes, and what do the graphs should exist? It is the opposite to each other, as what I have mentioned before. For the basic reciprocal function concept. Alright? So here are the general patterns of the RF that should be obeyed. Okay? So by right, the RF graph should look like a two parabola or the two catapult. Okay? So here, eventually here is the expected rational graph to be sketched over here. So I admit that my graph sketching is not that good, but I try to get the graph smoothly for your understandings. Okay? So here is the clarification that your RF graph must be smooth. Okay? As smooth as possible. Just try your best. And of course, your RF cannot be too truncated. Alright? So these are the wrong examples. Okay? If you draw the graph like too truncated and it's not smooth, or the graph is not balanced enough. So instead, just draw it steadily like this. So here are the proper ways for you to sketch a RF graph. Okay? So I believe most of you fell into the confusions. So let me repeat the procedures of the curve sketchings regarding curve sketchings of the RF. Okay? First, find all the asymptotes, but remember the fact that RF has two asymptotes only, at most. Okay, second, find all the intersections, x equals to 0 to find the y-intercept, y equal to 0 to find the x-intercept. Okay? And third thing is to find the domain and the range. Okay? Remember, x always real numbers except the VA. For range of the y, you have to take the b squared minus 4ac greater or equal to 0 to solve for it. The range of the y can be multiple. And then to find the turning points, usually you can use the quotient rule or the direct derivative if the long division is made. For the RF is improper fractions. Okay? And then solve for the derivative equal to 0 to get the x coordinate of the stationary point, and then substitute inside the function to get the y. So this is the stationary point to be plotted inside your rational graph. Okay? And then construct both x's, draw the asymptotes, plot the stationary points and the coordinate of x's, and then state the coordinates of x's as well. This is the high encouragement from me. This step is optional, okay? But if you feel like you are confident to sketch all the graph, and sure, please go on. You can go on, proceed to the graph sketching. But remember, when it comes to the graph sketching, your curve must be smooth. Although it's not perfectly smooth, okay, your hand must sketch it steadily. So to ensure that your graph didn't seem truncated. Okay, so What does the truncated mean? This means that your graph like the dashed line is seen, or the imbalanced curve, or the curve is not smooth, in other words. Alright? So yeah. Okay, another thing is there is a scenario that there is no VA. So what if this the QX equals to 0 does not have solution? This means that this solution, this equation can't be solved. How to know that this equation can't be solved? Okay, so let's assume that the QX is a quadratic function, or the degree of 2, the second degree of the denominator. So we can take here is the strategy. You can use the b squared minus 4ac, and then you solve for it. By right, the discriminant value is less than 0. And then explain why the RF does not have the VA. Because of QX equals to 0 can't be solved by referring to the denominator. So here, in the sum of the external partial questions, it got asked sometimes. Alright, so you have to know the fact, know how to justify the condition of RF didn't have the VA because of this matter. Alright? So far, if you find these procedures confused, you can reach out to me without hesitation. Alright? So I have explained it so long and I came here so far. Alright? Alright, I think I'll stop here. Alright? So in the next video, okay, we are going to explain about the relationship between the curves, okay, as well as the inequalities. This is for the behind part of the questions. After we have done about this, okay, we can proceed to the exercises for chapter 2, okay? Because this chapter is quite long, right? So I have to take more times to finish all the lectures and exercises. So this is the reason for me here to split this chapter in 2 videos. Alright? So thanks for watching. I will see you in the next video. Chapter 2, Rational Functions and Graphs Part 2. So long. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.